In this session, we are going to look at how innovation drives sustainability. In the chair, we have Professor Anirudh B. Pandit, Vice Chancellor, Institute of Chemical Technology, Mumbai. Professor Pandit has earned his B.Tech Chem degree from Indian Institute of Technology, Banaras Hindu University in 1980 and earned his PhD degree from University Department of Chemical Technology in 1984. From 1984 to 1990, he worked in the Department of Chemical Engineering, University of Cambridge, United Kingdom, as a research assistant and then as research associate with Professor J.V. Davidson, working in the area of bubble breakup and design of multi-phase reactors. He developed many novel designs of gas-liquid contractors and also developed new impeller designs. Professor Pandit is currently Vice Chancellor of the Institute of Chemical Technology, Mumbai. Prior to that, he has acted as Dean in his capacity of research consultancy and research mobilization and HR for 9 years. And to assist Dr. Pandit, we have a fellow alumni from his institution, Mr. Rupak Saraswat, who has now recently joined as the Chief Executive Officer for India Glycols. Prior to this, he has been MD for Transpec Silox and been MD for Croda India and MD Operations in Supply Chain Asia. He brings nearly 25 years of experience in the chemicals domain, working in various roles in operations, supply chain, and business management. Prior to Croda, he has worked for ICI India. Now the sessions are in your hands, Professor Pandit and Mr. Saraswat, and I hand over the mic and stage to Professor Pandit to conduct the session. Thank you.
Thank you, Mr. Misra, for your kind introduction and welcome you all. Thank you for giving me an opportunity to chair this heavyweight panel, which is going to talk about innovation drives sustainability. Now, in my opinion, it is actually a catch-22 situation. Whether innovation drives the sustainability or sustainability desire drives the innovation is a question which we all must try to answer. Many a times, the need to sustain yourself drives innovation because innovation is decided by the necessity. And in today's scenario, with chemical industry growing at a rate of 4 to 5%, and in India it is more than 6 to 7%, sustainability is a major issue which is handled, and Ministry of Environment and Forest is very, very keen that the chemical industry survives. At the same time, it is actually carrying out its practice in a sustainable manner. What we are going to discuss today is an able panel where a varied experience is available for us to discuss and to listen to, maybe question them. They bring out a different areas of sustainability, from new process development to conventional processes innovatively practiced. Now, this is what it's all about. Essentially, when we look at the sustainability, what one needs to look at is exergy analysis. The minimum destruction of energy is the one which is going to drive the process to sustainability. Now, how do we stop destroying the exergy? The appropriate use of quality of energy for the type of work which we need to carry out is the key to sustainability. No point in using high-end energy, high-quality energy for carrying out the operations or carrying out the processes which require a relatively low-grade energy. Just to give you a simple example, people might not be aware of. The simple electric geyser which we use, in terms of enthalpy balance, this heater is more than 95-96% efficient. But in terms of exergetic efficiency, its efficiency is less than 4%. That means 96% of the energy which electricity is, which is the highest form of energy, and we are using it just for heating up water, it is not really going to be sustainable. And that's why you can see a shift in India from electric heater to gas heaters, which is still a better option. This is just a point which I'm trying to look at. Every person, every practicing engineer, when he needs to look at the kind of anthropological activities, the kind of activities as an engineer he's trying to carry out, as a technologist he's trying to carry out, he has to keep the sustainability at the back of his mind. He needs to question himself or herself, is whatever action and decision which he has taken or if he plans to take, to what extent it is addressing the issue of sustainability. Look at the sustainability development goals of UN and keep questioning yourself if you try to bring out any innovation. Sometimes innovation is not necessarily sustainable. Innovation can be more profitable, but at the same time, this profitability has to be compared with sustainability. So I really look forward to these esteemed panels consisting of Lalit Handa from Spray Engineers, Dr. Laurel Harman of Lanzatech, Mr. Kishore Makwana from Rotofit, and Mr. Mukesh Malhotra from Salve India. It's a broad spectrum of experiences which we are trying to pull in here, and I'm really looking forward to it. I'll hand over the mic to my co-chair, Mr. Rupak Saraswat, to say a few words before we kick in. Thank you.
Thank you, Professor Pandit. It is an issue of great concern to all of us, and it is also an issue which can create tremendous opportunities, I believe, for the chemical industry. There are people here who will talk about various interesting technologies and what their organization and institutes are doing. You've given a perspective from a scientist, and I would like to step back a little bit and talk as a citizen of the world and also somebody who's part of the industry. To give a quick reminder, for example, the UN on the World Environment Day a few years back said 7 billion people, one planet, consumed with care. In short, they also said that at the rate at which we are consuming today, we need 3 planets. So we are already pretty unsustainable and down the path of destruction. In a year, we are destroying 50 million hectares of forest land, which is about 100 football fields a minute. In a day, a report said we are destroying 150 species. Now, species always get destroyed in nature, but the problem is that is about 1,000 times higher than what has been the background rate. Studies indicate that as high as 70% of groundwater in mainland China is not fit to touch. I'm not complaining only about China. It's just that I had data on one important country. There are enough problems in India as well. We are consuming aluminum cans in a year, which, if taken for 3 months, would be enough to manufacture the entire fleet of commercial aircraft flying on the planet. Many of us know that a train runs from Bathinda to Bikaner. It's popularly known as the Cancer Express. I was reading a report last year and it really troubled me, and I tried to do a cross-checking of the data by doing some simple calculations. It said that the ocean is absorbing heat, which is equivalent to 1 atomic bomb, which was dropped in Japan, per second. And, we are throwing away lakhs and lakhs of laptops per day and so on. Broadly speaking, let me step back and say that the chemical industry in the 40s, 50s, and 60s gave us new materials. It gave us new molecules, it gave us new processes, it gave us new applications, and it gave us new businesses or business models. Now, however, we are in a time when we are facing all these challenges, and we are in a time of radical change driven by sustainability challenges, driven by social challenges, and at the same time, a two-edged sword, which is technological advancements. And therefore, we must reinvent our materials, our processes, our applications, as well as business models. And in order to do that, I believe, therefore, it's a huge opportunity for the chemical industry to enter this new wave of innovation, which will help us deliver those new materials that are required through new processes, give new applications, and develop business models which are towards completely recycling what we are using and also creating the minimum waste. Unfortunately, referring to what Professor Pandit said, some of it is not necessarily happening in this direction. Chemical industry is often seen as more polluting, but as you know, 70% of the most toxic waste actually comes from the electronics industry. And we also know that the industry is operating in a manner where it's nowhere going down the line of recycling everything that we use. On the contrary, it is being based on business models which make us consume new things every year. Now, therefore, the need for a complete reverse supply chain, etc., is an opportunity. I think in India it presents, in my opinion, an even better opportunity because in some ways we were left behind. But I believe that this is our opportunity to deliver sustainable models to the world. This sustainability, living sustainably, is also in the ethos of this country, and I think that presents unique opportunities for us to innovate and deliver sustainability. I look forward to very interesting topics which the panelists here have to say. And with these thoughts which I had in my mind, I would give the mic back to Professor Pandit and for him to lead the discussion to the panelists.
Thank you, Mr. Saraswat, for nicely summing up the basic theme and the concerns and the opportunities for in front of chemical industry. So let me begin with the talk of Sri Lalit Handa. What I'm going to do is I'm going to take half a minute to introduce the speakers, and after all the speakers have given their presentations and talk, we will have a question answer session depending upon how much time we are left with. So let me welcome Sri Handa, Lalit Handa, who is the CEO of Spray Engineers Devices Limited. And looking at his background and CV, I can see that he is a person who has been involved in the optimization of drying and spraying operation. And I have done some work in this particular area. And unfortunately, drying and spraying operations are energetically extremely inefficient operations. If you consider a spray operation and the total quantum of energy which you use, less than 1% of energy appears in the form of a additional surface energy. Now that just gives you a huge opportunity to look at, and I'm sure Sri Handa will be in a position to address some of these issues during his talk. So I hand over the mic to Sri Lalit Handa to begin today's session on low temperature evaporator from waste to clean technology. Mr. Handa, please.
Thank you very much, Dr. Pandit. I'm overwhelmed to get the introduction from you, and good morning to all, and good morning to Mr. Saraswat also. As Mr. Pandit has very nicely described in very brief about the kind of a business we are involved in. Yes, we started our organization with the word spray, and we have done a lot of work. And I'm going to talk about today only about the low temperature evaporation technology, which is a new innovation in our kitty for last about 5 years, and it is picking up very well. It is a really a sustainable solution, and I find the good note from our honorable Prime Minister yesterday to the ICC conclave. It shows a concern, as well as it is a important part of our life for the future. And we have to really give the good sustainable future for our next generation. In context of that, I am going to talk about on water today, and I think next 20 minutes you will really like to understand from the points which I am going to present it to you, sir. Yeah. Good morning to panelists, and good morning again to the audiences ladies and gentlemen across the globe. Uh, my name is Lalit Handa. I am the Chief Executive Officer, as been introduced by Dr. Pandit, and I am going to talk about the low temperature evaporation technology, which is an innovation of our company and is patent technology. As our organizational mission statement says, we are dedicated for the sustainable environment development to unlock the perpetual and energy resources. You see, as Mr. Roprek has said that industrial water is not the major concern, but we find industrial water is also a major concern of polluting our water bodies and in giving us a pollution. So why the industrial water comes out? It basically come out as a residual after completing the process, which we need to complete to manufacture our end products. And this water, this discharge water, this industrial water or this wastewater is very much high in quantum. So this is a great concern to see that we use this water very nicely to make sure this water is in place for every one of us. There are many sources for the industrial wastewater, means distillation, chemical, paper, textile, sugar. They are the water guzzlers. They consume a lot of water and they discharge a lot of water. And when we are talking about the such a high level of water consumption, so discharge of this water is all not good to be given to the water bodies. We need to really make it happen back to the industry to make sure the industry reuse the water, because by grace of the god the water is the only element for us which can be used, reused infinite times, so we have to use and reuse water and let our water bodies to become as a natural source of water. This is a small statement from the UN World Water Development Report, which says over 80% of the world's wastewater and over 95% in the some least developed countries is released to the environment without treatment. I think this is a quite a big concern for all of us who are talking the sustainable environment for the future. So we have to take care about this very diligently and make sure that this number should reduce down in a scattered manner, so that we at the one day, maybe 30 40 years 50 years down the line, we are out of these numbers and we have a clean water for everyone. So these are some of the current stages where the wastewater is treated, like they remove the organic matter, suspended solids, organic and pathogens. So this is a very conventional kind of a wastewater treatment which is already going on in the industry. And this is a scenario, means it's a current wastewater treatment scenario where the wastewater, after screening, pH adjustment, equalization, primary, secondary, tertiary, then coming to the filtration, then coming to the RO, then RO rejects a lot, then from the RO reject goes to a multi-effect evaporator, the ATFT, and final discharge. So it is a quite a cumbersome process in which actually the wastewater which is coming after the process, which is actually a soft water, we make them hard and then again soften the water. So if this is a quite a complex and the multi functional activity which we have to look into it to cut down the processes in a interest to have a clean and better water continuously. If you see, we are talking about the low temperature evaporation. The water is continuously evaporating from the earth. This is the first process which is being developed when the earth was incepted. The water was continuously evaporating and the water boils at 100 degree, but there is no evaporation happening at 100 degree from the earth on a natural way. So the maximum temperature on the earth is around 50 degrees. So the maximum temperature of evaporation is 50 degree, whereas the water boils at 100 degree. So we have thought on those process, that natural process which is already available with us. Why not to try to evaporate the water at 60 degree. And when we go into the chemistry and the thermodynamics, we noted that water of 100 degree at atmospheric pressure is can evaporate at 20 kPa of vacuum at 60 degree. So we evolved a process which is a quite energy efficient process to actually evaporate the water at 60 degree, so that the energy can be controlled. And in the next slides you can see that there is a no need of the heat source in a continuation for the running the process. This is a current evaporation process. You can see a boiler or a turbine on the left hand side, and on the right hand side is the vapor rejection. So this process needs a heat generator as well as a heat rejection. So both are not good for the carbon footprints across the equipment. So they increase the carbon footprint of that particular area, and this is not a right propositions which we are looking for. And in my low temperature evaporation technology, there is no boiler, no turbine. It is a self-sustainable evaporation from the vapors of the liquid which is going to be evaporated. And as a result, there is no heat rejection. You can see the whole system now is working with the own heat, and the heat is properly balanced to make sure the evaporation is happening at a temperature of 60 degree with a negative pressure of 20 kPa. This is a small schematic, just to make clarity about how it looks like. If you can see the wastewater, which is gray in color, is going into the PHE, which is a plate heat exchanger, and from plate heat exchanger it is flashing down from the boxes, which is actually a heat exchanger boxes. And from the bottom you can see the yellow vapors are emitting, and these vapors are the low pressure low temperature vapors. And they become high pressure high temperature vapors by the change of enthalpy phase, and then they go into the horizontally into the evaporator, and from where the heat exchange program happens, and the condensed vapors come as a condensate in a blue color, and the on the right hand side the gray color, the vacuum pump extract the non condensable gases out of the body. So this is in nutshell, in a very small way, I tried to explain about the process, how it looks like. So in this whole process, first the vacuum is created, and then the whole process is driven out. This is a kind of an integrated process from the previous slide, where I have mentioned about the wastewater streams and then the clean water coming out. And in the whole process, you can see the water is completely recycled back. The wastewater which is coming from the process is given back as a condensate back to the process. This actually improves the process cycle. This actually improves the plant and machinery and the whole pipeline, as we are not going to use now the water. It is a distillate water which is going back into the pipelines of the industry or a factory. So this improves the life cycle of the equipments which consume water to process their end products. It is a fully automatic intelligent machine, and all machines are fully controlled from the back end from our control room, and we control and optimize the process as per the requirement of the process at the customer place. So this is a purely a automatic intelligent machine. So these are the factors which are governing the energy input to the evaporation process. It is a very nicely, coefficient of heat equipment, and where the extremely efficient heat transfer and vapor transport system within the evaporator U is taken care. A is the heating surface area of the heating surface, and which is also very nicely being calculated and being used. And delta T it is the extremely efficient vapor recompression technology is used, wherein the delta T for the heat exchange is starts from 1 degree and generally it ends at around 6 to 7 degree. So you can understand that this is a highly efficient equipment which gives a good output to the good output for the energy point of view. It is a plate type heat exchange. So we get the plates from our suppliers, supply chain, and the rest of the thing, the whole programming, whole assembly, and the manufacturing of the heat exchanger is done by us in house. And this is a completely patented technology. And you can see the one box which is a complete evaporator and a condenser. So there is no outside condenser, so there is no loss of the heat while we are actually condensing the condensate. And various kind of material of constructions are available for the heat exchange out, for depending on the salt proposition, depending on the organic or the inorganic propositions. So these are some of the major takeaways out of the LTE technology. No heat generator or a rejector, water recovery up to 99%, lowest carbon footprint, minimum sludge handling, no chemical treatment in the process, no reverse osmosis, so no concern about the disposal of the plastics. This equipment is purely manufactured in the stainless steel, as I mentioned. Lowest water recovery cost, lowest most effective water management solution, direct wastewater to clean water in a single step, closed loop, robust and automatic system. Some of the case studies from the chemical point of view I am going to share about. This is in Bear Vapi, where our equipment is working for last almost now more than 7-8 months, and this is a pilot plant to validate the process. And I have been informed that they have already start validating the process and going to commercialize the whole process within their premises. And you can see the inputs of around 18% solids with a COD of around 2.5%. They are getting a water of TDS of around 180 to 200 ppm in a single stroke, and the reject of 35% solids is being given to their ATFT for disposing out. So this whole system actually validate that it is possible to recover the water of any stream of any total solids from the wastewater to the clean water. Another in Vapi, it is in a Supreet Chemicals. This is again a dye-stuff manufacturer where the water recovery is around 80%, and this water is being consumed by them for their cooling water requirements. And this plant is running continuously for last more than a year now. So where you can see the TDS of around 152,000 ppm coming out as a 120 ppm. So it is a single stroke. There is no chemical, there is no inbuilt process, the directly an evaporation process to evaporate the water and take the distillate out. This is the most chronic problem of the world, the distilleries. Distilleries discharge a lot of spent wash, and we have supplied the equipment of around 300 cubic meter, where this equipment is already commissioned in Kenya, and they are able to continuously pass their daily production of around 220 cubic meter of spent wash through this evaporator, and they are not passing to the lagoons. And slowly and slowly they start cleaning their lagoons, and probably in some time their lagoons would be out of the spent wash, and then they would be able to use this water maybe for agriculture or maybe recycling the water, because the so much of water is not required in house by them. So probably they will do for the agriculture and disposal to the other authorities. You can see the total solids of around 23% and they get the water of TDS of around 100.
Mr. Handa, we have lost you. Are you disconnected by any chance? ICC host, can you just try to bring Mr. Handa online again, please?
We are trying to. Yes, we are.
Okay. Yeah, thank you.
We are trying to clear out the screen so that then we can start the next presentation. So we are trying to from the optimized side to shut down this screen so that the next presentation can start.
Sure, that's fine. I was about to suggest you the same.
So can we start with Dr. Harman's presentation?
Yes, I was about to suggest the same. I think if you can get Mr. Handa online later on during the QA session, whatever few slides were missed out, maybe he can present it at that point of time. So let's move on to the next presenter, Dr. Laurel Harman from LanzaTech. And I can see from her short CV that she's the one who seems to have a global picture clear in her mind, and all the LanzaTech based activities which are currently happening all over the world, including the one which they are currently negotiating in India for Steel Authority of India Limited at Nagpur for the recovery of steel mill off gases to convert it into ethanol. I'm well aware of these, and I'm really, I think this is one of the major innovations in the area of chemical industry where a renewable or a waste has been used and looked at as a resource, irrespective of what its composition is, and a genuine attempt is being made to convert this in the form of useful products as well as fuels. So welcome, Dr. Harman, for this seminar, and I give you the mic to make your presentation. Thank you.
Thank you so very much. I really appreciate the chance to be here and to share with my panelists and all of those who are watching, just give you an idea of what we've been doing. My first goal here is to actually share my slides. So hopefully you can see the slides now.
Yes, we can see. Thank you.
Thank you.
Go ahead. Yeah.
So in the prior presentation, you were hearing about water as a recyclable resource and one that we should think in a very different way. LanzaTech's view is that carbon must be thought of in the same circular way. We all know and are moving toward a world in which energy is free of carbon requirements, but this audience knows above all that we're going to continue to need chemicals and fuels based on carbon. And what is really going to determine the sustainability of our future is where we get that carbon from. So LanzaTech was founded with the idea that there are many sources of waste carbon in our world today, some of which we originate, some of which we don't. But that we need to think of that carbon as a resource and something to be captured, used wherever it originates, and turned into those materials and chemicals that we need. And so when we think about circularity, we actually think in terms of not a circular material economy, but a circular carbon economy. And that this is the way ultimately we will reduce our dependence on those fossil resources, which are our primary source of carbon today. So I'll talk about the technology that we've developed. I just say here that we are a privately held company. We are headquartered in the US, but we have a growing presence in India, and some of my colleagues are participating today. They, in fact, would know more about some of the most recent projects, but I'll tell you a little bit about some others in India. We have a very diverse and global set of investors, as you can see down at the bottom. I would like to highlight that Indian Oil is an investor, as well as building a project, which I'll tell you more about. So we are, as a company, in thinking about sustainability and our goals, look to biology as the best way to harness carbon, to access carbon wherever it may arise. And biological systems can do things that we cannot emulate in man-made technologies or our chemistries. And a couple of the really important things which we, in a way, take for granted. One is the ability to replicate themselves. So in effect, you've got a machine, a substance, a catalyst that's continually reproducing for you as opposed to needing to be manufactured. And they are programmable. Now, we turn to biology that is ancient. The earliest forms of life actually originated in an atmosphere that was highly reduced, very rich in carbon monoxide, carbon dioxide, as well as other gases like methane and hydrogen. And coincidentally enough, that's also the type of atmosphere, if you will, that's produced from industrial processes today in the form of emissions. And so, as the company was founded in 2005, it set out to look for those life forms, those organisms that originated in that ancient atmosphere long before oxygen showed up on the Earth, and to harness their metabolic pathways as chemical manufacturing systems. These are a family of organisms called acetogens, and they have a fairly unique ability to actually get all of the carbon and energy they need from carbon monoxide alone. In the presence of hydrogen, they will also get carbon from carbon dioxide. They're incredibly flexible and robust organisms, and they are still around natively today. So we took these organisms, which then we're treating as a biocatalyst, and we selected a particular platform and built around it a gas fermentation process. So this is very much like conventional fermentation, except in a couple of key features. One is that the input is gas rather than sugars. And the second is that it's a continuous process, and in that respect is more like a refining process in which gases are continually fed into the process. Excess biocatalyst is removed along with product. So we're continually producing, separating, and storing the product. Our first commercial targets were, in fact, the industrial off-gases that were so much like the native feed, if you will, for our organism. Looking toward the future, with the advent of direct air capture technology and the parallel availability of renewable electricity, that means that we will be able to feed either carbon monoxide produced by electrolysis of CO2 or carbon dioxide and hydrogen from electrolysis of water directly into exactly the same fermentation process. And through technology called gasification, which produces syngas, primarily CO and hydrogen, from solid materials such as agricultural waste and municipal waste, once again, the same fermentation process can be fed actually to produce exactly the same products from solid wastes. In terms of product slate, that's really where I'll focus today. We have a wide range of both direct fermentation products and downstream products that come from subsequent chemical conversions. And then to close the loop, if we think about non-recyclable materials, so those which cannot be physically recycled, that have been made out of this waste carbon, because of the ability to use gasified waste, they can all be turned back into raw material for this process. So in that way, it's fully closing that carbon cycle. So this is not science fiction. Our first commercial plant is operating in China at commercial scale. To date, it's produced over 20 million gallons of ethanol, which is our first commercial product. And this is being produced from the off-gases of steel manufacturing. So this plant that you're looking at is sitting right at a steel mill, being fed steel mill off-gas, going through that gas fermentation process and producing ethanol. And in doing so, that quantity of ethanol product is equivalent to over 100,000 tons of CO2 being prevented from emission into the atmosphere. So another way to look at a process like this is as carbon capture and utilization. Another strength of biology is its tremendous robustness. And for those who are more familiar with thermocatalytic systems, you'll appreciate how different biology can be. If you look at this left-hand side, this chart is showing the time course of hydrogen to CO ratio from MSW syngas. So this is a case where you've got unsorted and non-recyclable municipal waste, which is therefore fluctuating in its composition, the material composition, therefore fluctuating in gas composition as well as contaminants. If you fed this into a typical thermocatalytic system, those who are familiar with the industry and the chemistry would recognize that this would be very, very difficult, really impossible to manage. What you see here is the operation of gas fermentation during that period. And what's happening is because we're using the intrinsic metabolic pathways within the organism adapts in the same way that it adapts from having, a varied diet. How our organisms ourselves adapt as we vary our diets. And so it is very robust to fluctuations and to contaminants as well. And that is a real world example, and it comes from the system that you see here, in which we have been operating since 2014 on operating this fermentation system the same as is implemented at the steel mill, but in this case, operating on syngas produced from unsorted, unrecyclable municipal waste. And this is a pilot facility in Japan that is now being scaled up. The technology is being built out around the world. Here in India, or there in India, since I'm sitting in the US, it is being implemented for the very first time on refinery off-gases by Indian Oil at the Panipat refinery. And a very recent project is one which will use agricultural waste as a feedstock with gasification provided by Ankur, an Indian gasification company, and that's a project for MRPL. You'll see multiple plants in both Europe and China using steel mill off-gases. There are new plants in development that are using ferroalloy off-gases. The municipal waste I've already mentioned, and now a specifically focused plastic waste recycling project in Europe, which just shows, I think, through the course of these projects, you can see the diversity of feedstocks that are suitable. Here you see 3 of the plants in construction. In the middle, you see the Indian Oil facility that I mentioned. These are older photographs. It's a little hard to keep up with the development of a new facility, but it gives you a taste. And on the bottom, an ArcelorMittal facility in Europe, in Belgium, and at the top, a new ferroalloy plant in China. So the first application of ethanol from the China facility has been for road transport, and that's typically what people think of as an application for ethanol. But ethanol itself is also used as a chemical. And we recently announced the delivery and use of ethanol from that plant in China, so ethanol made from steel mill off-gases that is being incorporated into cleaners in Europe and marketed by the Mabel Group. So those are direct uses of ethanol, ethanol as a solvent, ethanol as a chemical. Now we can talk about derivatives of ethanol. And what we start to talk about here are what we call carbon smart products. So chemicals from waste carbon that are incorporated into other types of goods. Ethanol itself is a building block, and the easiest entry point is through dehydration to ethylene, which gives access to the entire value chain of that ethylene in the chemical or petrochemical industry. One avenue is through oligomerization to olefins, and that we have focused on for the production of jet fuel. However, through other chemical transformations, got polymerization to polyethylene, production of MEG, and I'll talk about some of these applications as well. So ethanol is a building block itself. I won't say much more about the aviation application, except to say that we have flown commercial flights using jet fuel that we produced from ethanol. We have ourselves launched a new company, LanzaJet, whose sole purpose is to commercialize that particular technology, and the first production facility will start up in 2022. We recently announced publicly the production of the first plastic bottle, polyethylene, made from steel mill emissions. And this, again, this is how here it's polyethylene made from ethanol that came from steel mill emissions produced in China. And that's been a collaboration with Total and L'Oreal. An application that's a little closer to home, and one of your session chairs would be very familiar, is the application of ethanol as a substitute for petrochemical ethylene. And we have collaborated with India Glycols, who has been for a long time producing sustainable MEG from ethanol. And we have now collaborated to provide ethanol from the steel mill plant in China to be converted, has been converted to MEG at India Glycols facility. And then the MEG has been transported to Far Eastern New Century in Taiwan to be used as an input to PET. And that PET will go to a variety of customers who are interested in recycled carbon for applications such as textiles and other materials. I mentioned not only is ethanol a product, but because we have developed the ability to tailor the actual metabolic pathways in our organism through synthetic biology, we have the ability now to tune and produce a variety of other direct fermentation products, so not requiring downstream conversion. One example of that is acetone. Acetone is typically produced as a byproduct of phenol production using the cumene process, which has its own environmental drawbacks. And the cumene process is actually decreasing in the market as a whole. What we have done is to tune the organism to produce acetone in our gas fermentation process. And we have shown that 90% of the carbon input is selectively delivered as acetone product, with the balance then simply being the biomass, which the organisms themselves have to produce in order to survive, and a small amount of acetate. This highlights another advantage of biology, which is selectivity. We are also working on a direct route so that MEG can be produced directly as a fermentation product without even having to go through an ethylene intermediate. This slide just gives you a taste of the range of chemistries that we've demonstrated at commercial scale, at pilot scale, where I mentioned acetone. We've demonstrated isopropanol and 2,3-butane-thiol in pilots, a wide range at the lab scale, and an even wider range as proof of concept. And in fact, we have an extraordinarily detailed and faithful model of our organism's metabolism, which has allowed us to show that there are at least 500 different molecules accessible through this particular organism, all produced from gas. So what this is doing is really providing an entirely different model of chemical manufacturing, in which instead of having to predict what the market will be 5-10 years from now and provide those capital investments, instead, we can think now of the separation of the bioreactors as hardware and the microbe as software. And instead of having to change all the hardware, develop a whole new capital investment, instead swap out a microbe. And as either the market changes or new microbes become available, then this can be turned around. A facility manufacturing one chemical can be turned around in a matter of weeks to produce something new. And so what that really results in a very disruptive view of manufacturing, which is no longer long predictive type cycles associated with high capital investments, but instead becomes one in which there's rapid reaction to the market. So just in summary, we have ethanol as a product itself, ethanol derivatives, and then all those new chemical products that are accessible. And as a consequence, then we really are closing that carbon cycle and creating the basis for a circular carbon economy. So thank you very much. I hope I've given you a taste, and I look forward to the remaining presentations.
Thank you, Dr. Haman, for an outstanding presentation. And it is indeed the fact that we can learn many things from nature. Nature is the most efficient optimizer of the resources, and there are many processes which we can learn from nature. The only thing is, nature has all the time in the world. Unfortunately, we don't. So, how to speed up the activities which are performed by nature for engineering scale application? And I'm really impressed with this particular approach of synthetic biology put to use for industrial chemical manufacturing using most of the waste carbon. Thank you very much, and I will take up some questions later on during the QA session. Let's move on to the third speaker of the day, Mr. Kishore Makwana from Rotofit Engineers Private Limited. Now, as far as Mr. Makwana's expertise goes, his expertise is, in addition to being associated with ICC and looking at it, he has also been associated with TechMac engineer firms and specializing in handling of solid liquid equipments. Since he is a trained BARC scientist or has completed the training school of BARC, I am sure in terms of its competence of translating the science into technology, there is no better representation for the same. So I really look forward to Mr. Makwana's presentation, which he is going to talk on solid liquid separation technologies to sustain or improve improved environment. Mr. Makwana, please.
Thank you very much, Dr. Pandey and Mr. Rupanakar, as well as my fellow speakers. I'll start with my presentation.
Mr. Makwana, your voice is cracking. Your voice is not at all clear. You need to come near the mic, near the microphone. Otherwise, it is not going to be audible to anyone. You need to either wear the mic or come very near the mic. Bring your sitting position very near the mic. Otherwise, your voice is cracking. No, the audio is really bad. Your voice is cracking.
Mr. Makwana, use the mic from only one device. I think more than one device leads to this problem. So just one device mic, please.
Hello. Hello. Now the voice.
No, it is still not. Your voice is cracking. It is not clear. As if there is some loose connection somewhere.
So now voice is clear?
No, it is still not.
Sir, I suggest that while we connect with Mr. Makwana's office and
Yeah, I was about to suggest, I think, can we may I request Mr. Mukesh Malhotra to fill in if it is possible for him and if he is ready?
Yes, I can do that.
Great. Thank you very much for bailing us out. I think these two things do happen as far as technology goes. So let us move on, and let me now invite Sri Mukesh Malhotra, Country Manager, Managing Director of Solvay, who again will bring in an international flavor in continuation with what Dr. Harman talked about. Now, Solvay again has been involved in the manufacturing of specialty chemicals and has been environmentally very conscious. In fact, all the industries who are, let's say, international industries, whenever they come to India, one has to think in terms of sustainability, and Solvay is playing its role in that direction. So he is going to talk on emerging green technologies for sustainability from Solvay's angle, and I look forward to Mr. Malhotra's presentation. Mr. Malhotra, please.
Thank you, Dr. Pandit, and thank you, ICC, for inviting me to share what Solvay is doing in the field of sustainability. As you mentioned earlier in the beginning, it's actually sustainability which is driving innovation rather than the other way around. And a colleague of mine shared the site with me earlier, which I thought it would be a good to look at. Bloomberg put out a kind of a dashboard, and this is of American companies, and you can see all the big names there. And if you go to their site, you click on these icons and you will see the commitments made by different companies, and the color coding actually represents their progress. Green is already done, blue in progress, red behind, and black which one they are not reporting. So sustainability is something which is very, very important and has been embraced by industries all across, not only chemical companies. Chemical companies with all what we also deals with the perception of being a most polluting industry, I think has a major role to play to drive the sustainability into the marketplace. First, few things about Solvay. We are about 156-year-old company founded by our founder, Hans Solvay, who believed that science will derive the progress of mankind. And with that, he started to connect with the best minds at that time. And he would have an annual conference. This is the picture of the first conference. And you see some famous names there like Albert Einstein, Marie Curie. And I think the more famous picture is of fifth conference, which happened in 1927, went around on LinkedIn a few days ago. There were about 29 attendees. 17 out of them went on to win the Nobel Prize later. So the innovation has been in our DNA, and the spirit of connecting or bonding is today defining our purpose. So we exist to connect people to people, ideas from different resources, and then, of course, join our chemical elements to reinvent progress. And our vision itself is to create sustainable shared value for all. And when we say all, we mean everybody in the community, whosoever has some stake. So it's actually value which goes beyond ourselves, our stakeholders, our customers. It is actually for community at a large. So today, Solvay is a material and science company. We have plants across 64 countries, more than 24,000 employees. And today we boost off more than 53% of our sales coming from sustainable solutions. We talked about sustainability driving innovation, and sustainability requirements come from the business trends. And that's what drive our strategy. If you look at the major trends around us, electrification, which is going on in big way to reduce our reliance on fossil fuels. It is predicted that probably 50% of the new cars produced by 2030 would be electric cars. Air travel, you need light weighting to save fuel. Digitization, again, would need energy. All these are basically screaming for sustainable solutions. Because if we were to use the energy, which is one of the biggest emitter of carbon dioxide, it's going to become very, very difficult. So with that, last year, we launched a program called Solve One Planet, which was basically adapting bolder objectives to solve key environmental and societal challenges. And we made our goals public, and I'm going to share some of those. It's basically on the climate, where we have pledged to align our greenhouse gas emissions in line with Paris Agreement. We will reduce them by 26%. We've also put a stake in the ground that by 2030, we would not use any energy generated by coal. And we have majority of it today coming out of coal for us. Of course, safety is a priority. And as I mentioned earlier, that we want to continue to keep revisiting our product portfolio to make sure that our revenues from sustainable solutions increase to 65%. And we're also looking at circular economy. The circularity of our products, we intend to double from today's 7% to 15%. We not only do this, we actually are devise the system to measure all this. We created our own methodology, what we call sustainable portfolio management. And this looks at our products from what we call cradle to grave. That means we don't only look at the emissions or the impact at our own factories, we look at it across the chain, right from our suppliers to our customers to the time they end up with either recirculate or end up in the landfills. So, for examples, we have our high dispersible silica, which now reduces or increases the lifetime of tires by 15%. That means if you translate that, it will be a reduction of 1.8 million tons of tire materials every year across the globe. So with those commitments, what are we doing and what technologies are coming up? We see, since Solve is a diversified company, we deal in different chemistries. So we see different ecosystem emerging and innovations in each field. And I'm going to touch on some of them right now. We also joined Ellen MacArthur Foundation to promote circular economy. We've recently signed a partnership with Veolia to renew the life cycle of electric car batteries. As we talked about, electrification is something which is bound to happen. And we are using our metal extraction technologies to be able to extract the metals from the batteries, or the black mass, as we call it, when the batteries is spent of the life finishes of the battery, to extract the metals like cobalt, nickel, or lithium, and put those high purity raw material. You basically convert them again into high purity raw materials so that they can be again used to make new batteries. We're using rice waste, actually the acid drawn from rice bran, to produce natural vanillin. We are the world's largest supplier of vanillin, and we are also the world largest supplier of natural vanillin now. And that comes through the fermentation process, which we put in from the acid extracted from rice bran. Energy, boilers, we're moving away from coal, as we said. We've taken about 27 projects across the globe on our different factories, which will result in about 885 kilotons of carbon dioxide emission reduction, including in our plants in India. Today, our plants in India, about 36% of our energy comes out of renewable resources. Some of the products or the technology which we developed on sustainability in terms of composites, the next generation material, which we can use with the existing infrastructure. We all know composites are much more efficient, lightweight, and results in low energy consumption. Then, based on natural guar, the guar which is produced in India, we use that as a basis to bring out solutions for hair care, for body wash and shampoos. We have then high performance polyamides, which are highly glass filled, and these are basically designed for structural components, and they offer the same benefits as you would use from the other petro-based products, except that these are bio-based. Battery materials, we talked about it. We are actually part of European Battery Alliance, where we are playing a key role in building battery of tomorrow. And the battery of tomorrow, as you know, is being built with the objectives of 500 to 800 kilometer of range, 30 minutes to recharge, up to 80% of the life. And the life of the battery itself should be equal to the life of the vehicle. That means plus minus 12 years, you could say. So that means one battery throughout the life of the vehicle. This will be an immense technological leap where we're playing a big role. We actually already have some safer polymer electrolyte technology, what we call Solgain. And that actually replaces the liquid electrolyte, which is extremely flammable and currently used in lithium-ion batteries. And this is kind of a gelled polymer which replaces that. It not only improves the performance, but also makes it much more safer. Then, as we all know, millions of clothes are discarded each year. And we came up with a product called AmniSole, which what it actually does is it enables garments to quickly decompose when they are discarded and left in the landfills. Coming to the agro side of our business, we again try to solve the problems of nitrogen loss. We do have solutions, more bio-based, again, into the whole crop protection, pre-harvesting and post-harvesting, different solution. But the one I want to talk about here, which stems the nitrogen cycle losses, we tested that even in India, where it can be worked. These are kind of additives which can also go with neem-coated urea. They not only improve the yield by 10%, they also reduce the consumption of urea by 15%. So if you just imagine for a country like India, where the government provides subsidy, it not only amounts in savings in subsidy, but it also reduces their import bill because we import quite a lot of urea. So it's win-win for both, and also regenerates the soil, reduce the nitrogen cycle losses. Similarly, on the phosphine, when we talk about post-harvest crop protection, even today, while shipping, the people use methyl bromide as for fumigation, which is basically an ozone depleting product. And we are one of the 2 companies in the world which came up with a cylinderized phosphine gas for the same application, which has no residues, no traces, and no risks. 3 more I want to talk about. One which is, I think, attracted a lot of attention during the current scenario of pandemic. ActiZone, which actually is an technology where it not only cleans it better, but it continues to work for 24 hours. It basically forms a layer on the surface, and even when it becomes dry, they continue to fight the germs, and it cleans 99.9% of the germs up to 24 hours. So imagine using these in the public spaces, the hospitals, in the buses, and you can be assured of having germ-free seats to sit on. Then we've come with the hydrogen platform, which we recently launched. Solvay has proprietary membrane technology based on conductive polymers, and we're using that for the production of hydrogen via electrolysis. Then onto the agro side of business, we have additive-based technology for a special film, which we use in the greenhouses, which practically improves the photosynthesis. And for example, for tomatoes, they grow much faster because of the improved photosynthesis. All this is done in our different labs. A lot of you may be aware of our association with the Solar Impulse, the plane which went around the world without using a single drop of fuel, also came to India. Solvay has been partnering with Solvay Solar Impulse Foundation since very beginning. And after the completion of the solar plane, we've joined them with what we call World Alliance for Efficient Solutions, which is aiming at putting 1,000 solutions in the world to improve the quality of life on Earth. So there's a labeling process which will judge the products for its sustainability and contribution to the improvement of life. The aim is to get 1,000 such solutions. Solvay has already qualified 10 of our products. They are today labeled as of last year under this. All this happens again in 21 R&I centers across the globe. One of them happens to be in India, in Vadodara. Across the world, we have 2,100 scientists working, developing all sustainable solutions. And our R&I center in India focuses more on performance polymers, nanocomposites, and green chemistry. As I said, we look at across the chain. We also launched in 2015 along with an NGO, and then one of our customer, L'Oreal, joined the program for what we call a Sustainable Goa initiative, which is basically looking at improving the livelihoods of Goa farmers. Today, it covers about 7,300 farmers in Rajasthan, the district of Bikaner, and that also includes about 1,500 women. And these women have developed their own kitchen gardens, and we have today about more than 885, say close to 900 kitchen gardens. So that was the flavor of what we are doing as Solvay. Our initiatives are well recognized. You see different agencies giving us ranking. Our US ranking, we are in top 10 in terms of sustainability commitments, and in top 100 in the globe. as a sustainably managed companies. So I hope I have been able to give you the flavor of what we are doing. And I would just say thank you for giving us this opportunity.
Thank you, Mr. Malhotra, for a very nice presentation, just showing and showcasing the initiatives of Solve. And indeed, what you said is so true, is similar to as our co-chair had said that, and you also said in the beginning, that science will drive the growth and progress of the society. At the same time, I am pretty much sure about the fact that science is the one which is going to find solutions to all our problems. But as also Einstein said, that not the same science which created these particular problems, we need to look at a different science to find different solutions to this. Thank you very much for your excellent presentation, and please wait for a QA session, which we'll have it after the last lecture. But before I move on to Mr. Makwana, may I now request Mr. Handa, who had missed out last few slides, to come over and then make that remaining presentation before we move on to Mr. Makwana. Can I request Mr. Handa to continue his half-completed presentation?
Thank you.
Yeah, Lalit bhai, please go ahead.
Thank you. Can you see my screen? See?
We can't see it yet.
Okay.
Mr. Makwana, I can run it from the background for you.
Yeah, it will be better. I think we are already running slightly late.
I'll share that.
I think please go ahead and share it. Yeah. Go to the slide where he got disconnected.
Yeah.
Yes. I think
the second case study of of the industrial case study. It was second.
Go ahead,
please.
Yeah. Go ahead.
Go ahead. Yeah, this is where it stopped. I go to the third one, I think.
Yeah. Next. Yeah.
Yeah, this is where we stopped. Correct.
Yeah. So this is the case study about a distillery where we have handled the spent wash of around 350 cubic meter per day, and with the total solids of around 23%, and the condensate they cut of around 120 to 200 TDS. And the reject is a concentrate which is a organic in nature and is being handled separately. So this is how about the Kenyan case study for the distillery point of view. Please go ahead.
Next, please.
Yeah. So wherever there is a water, we have a solution for the industry, and this is a completely a sustainable solution. In this solution, there is no chemical, there is no heat source is required, and it is the best solution for the industry to take over the things for the sustainable solution, sir. Please go ahead, sir. So we have a lot of installations across the country, and the one we have in the Kenya, that is in a distillery. So we have a quite a substantial reference across the country to showcase our strength and equipment as well as the sustainable technology to our prospective partners. Please go ahead. We were awarded niche company by the CI Triveni Water Institute for excellent in water management, for which they did a complete validation of the process for almost 7 months before we were awarded in 2019, sir. Please go ahead. We have an office in Chandigarh, and our manufacturing facilities are in Badi. We have 3 factories in Badi to produce our equipment for the supply to the country as well as across the globe. Please go ahead, sir. Thank you very much. Thank you, Chairman. I appreciate for your consideration to showcase my last 5 slides to cover up my presentation. Thank you.
Thank you, Mr. Handa, for being ready. And I think please wait when we get to question answer sessions. Now, may I just turn our attention to Mr. Makwana? If Mr. Makwana is ready and his audio issues have been sorted out, may I request him to make that presentation?
He's there, he's just joining. He's getting admitted. Mr. Makwana, please go ahead.
Hello. Can you listen?
Mr. Makwana, please go ahead. Say something.
Hello. Good afternoon. Can you listen to me?
Yes, I can hear you.
Very clear now.
Now it is
It's
clear?
very clear now.
Yeah.
Yeah.
Now it is, yeah. Right. Shall I have to start?
Yeah, start sharing your screen.
Hope you have received it. Can you see?
Not yet.
Mr. Makwana, let me run your presentation from the.
ICC, can you run the presentation for him? Mr. Makwana can talk.
Yeah.
Yeah, please go ahead. Mr. Makwana, please go ahead.
Right. Can you go back first slide? From the first slide. On behalf of Rotobuild, I thank you all for sparing your valuable time with Rotobuild and giving us an opportunity to talk on solid liquid separation. First of all, let me apologize for what has transpired back. Somehow that connection and other thing, there were some issues. So now I am through laptop. That is one thing on the line. I have to say next like that, or I can do it from here.
No, you'll have to say next when you finish talking about one slide.
Yes. Next. Solid liquid separation technology is to sustain or improve the environment. Solid liquid separation consumes. Next. Click. Sustainability improves if we reduce consumption of the resources, because any reduction in resources will improve the sustainability as well as the environment as well as the economy. Next. solid liquid separation, one of the steps to process industries leads to a product as well as effluent, consuming a lot of resources. So whenever we talk about a subject, it is a efficiency. Solid liquid separation efficiency, if we think it as iceberg, it becomes very easy to understand. Next, click. Whatever we are seeing at the top of it, it is a tip of iceberg, which is nothing but the mechanical equipment, but there are a lot of hidden things which affects the environment, enhance the power consumption, increase wash liquid, because whenever we do separation, we remove the impurities from the solids. Next, sometimes we use the inert gas as well as air, so increase in consumption of air. Then ultimately, when you take it out as a mechanical separator and as a product which has got a moisture, which enhance the drying cost. Next, and maintenance. It's a downtime, a lot of manpower involvement into this. So immediate question comes to the mind, how to sustain or improve in environment. Next, Rotofilt is 100% focused on solid liquid separation technology. The product development is our prime criteria, and it is all products are 100% indigenously designed and developed. That is next. Second, then now we have started as an application engineering, because any chemical industry needs to have an input condition and looking for an output condition. If we provide any box in between which serves their purpose, that will work out. So we started an application engineering of it. And then the support system, because for any capital equipment, lifetime support is very important. So that is what we have started, and we are working on it. Next, if we take it as a Rotofilt journey, we started first with pusher centrifuge, then we did decanters, then we did peeler, vertical basket. We got an R&D approval by DSIR. That is one thing. Then we did automatic vertical pressure filter, inverting filter centrifuge, as well as R&D. Now we are working with DSIR to have R&D at site, because anything you do it in-house is not being tested at the site, it has got no value. So that is why we are now working with DSIR to have an R&D at site. Today, I am taking it as an automatic vertical pressure filter as a product, journey of that, operations of that, and then case studies of it. Next, click. Pusher centrifuges, we started 2002, and the project was funded by Gujarat Venture Finance Limited. Then we did 2004 decanters. Then we did peeler centrifuges, because some of our known customer wanted to have a equipment which is conventional. So we derived out and we designed that. Then we did vertical basket. Mainly we are doing bottom discharge. It is all semi-continuous products. Next, it is AVPF 2009. This project was funded by Technology Development Board by Ministry of Science and Technology. Next. Introduction to automatic vertical pressure filter, because that is the product. I will take it as a journey, because it's going to be game changers in chemical industries. We have already done a lot of work with pharmaceutical industries, and it has worked out very well in pharma industries. That is the things in API. So gradually we are entering into chemical also in a big way. Next. Operations of automatic vertical pressure filter. I'm now taking it that way of the things, which are the way. There's any equipment has got an operations, how it operates. Next. First is feeding, second is pre-squeezing, third is cake washing, fourth is final squeezing, then air blowing, and next is cake discharge. So this is the first step when the feeding is, because there are individual chambers on the line. When the feeding is taking place, that time the filtration is taking place, and the chamber is, controlled chamber. It is a 50 millimeter to 60 millimeter, depending upon the model as well as the product. That is the way we work out and then operate. Next. Then pre-squeezing, there is a membrane in between, or we can call it as a diaphragm in between, with the water being a non-compressive. So consumption of power which is reduced on the line because of that. Ultimately, delta P across the cake matters. That is the thing. See, it's a pre-squeezing is done where the product is to be washed. When the product is not to be washed, it is to be final squeeze. Next. Then, if the product is to be washed, whatever the wash liquid is required, according to that, it is to be washed. It will be a displacement wash. So the consumption of the wash liquid reduces a lot compared to any type of filtration equipment. Next. Then the final squeezing. Final squeezing is done with the 16 bar. Delta P across the cake is 16 bar, can be generated in this equipment, whereas no other equipment, if we talk about centrifuges or anything, if you talk anything about a vacuum, delta P is hardly about 1 bar. This is 16 bar. Next. Then further, if you want to dry, we can blow the air. Sometimes people are using, means if the product is not compatible with the air, it is a nitrogen, or it can be with the little hot air also, it can be done. So it can be further dried. Next. Then it's open up. Each and individual filter plates are being opened up and cake is getting discharged. If somebody will like to see the operations as a working on these equipments, we have already put up into exhibition. There is a video on that. One can go through it and see it on that. Next. Next. When we started AVPF, this was the first AVPF which we designed. These photograph has been taken from the commissioned site, and it has been edited. This machine is also working today. In 2010, it was commissioned. It is working today. Then next. Then we further developed to this. Next. Then we further modified to this to cater to pharma industry for CGMP construction. Next. This was done for pigment industries, developed to make it suitable to pigment industries. Next. Then we did it totally enclosed equipment where environment, product is sensitive to environment and all. So this has been done for one particular case. Next. This equipment was derived for the solvent. Next. Next. This is further developments because we have taken a pictorial journey how we have moved. So seeing is believing. Next. This is 100 PP, contact parts has been developed for exotic material. Next. This is now new generation. Next. Next. This is as on today. This is the development. Gradually we have done it because depending on, we have exported the machine also. It is CE mark, ATEX approved. These are the things. Next. I'll take you to our production line. This is our production line for centrifuges. Assembly shop, you can say that. Next. This is for peeler. Next. I think picture is not clear. It has not come. Anyway, this is a bottom discharge 1600 dia. This is first time developed and designed by us in India. Next. This is AVPF assembly line. Next. This is the cake discharge videos we have taken. Hope video will work out, possibly, because these are the different product where the cake is getting discharged. We have taken up as a small clip. Is it possible to click on a ABPF cake discharge? If it has been shared, it can be.
ICC, maybe one or two videos can be shared rather than going through all, just to explain the principle of operation.
Principle of operation is already there in our exhibition. If anybody wants to go into the exhibition, there is a booth and there are videos which has been kept. So the videos are already there. Or if some...
Actually, we are unable to run the videos. The links have been disabled on this presentation. So participants can visit the booth of Rotofield in the exhibition given in the tab below. And from there you can view all the videos and projects.
Right, that is the thing. And anybody would like to see further on that can contact us. We can definitely share with them. See, basically, speaker has already spoken in past that there should be a business model to be changed with the time. This is what the business model we have developed for solid liquid separation. We interact with the end users. Mechanism is being provided by us. What is processing is to be done. We get this information, click next. Next. So we select the mechanism, conduct the trial, analyze the trial report, understand the capacity, what exactly the company is looking for, finalize the equipment, and equipment which is being designed and delivered ultimately gives low downtime, low maintenance, low moisture, low energy consumption, and competitive advantage. Next. These are now some case study. I have put up only 6 case study here, and whatever is the data is being given by the company that has been tabulated in this form. Next. Right. The product is one of the intermediate. What they were using earlier were ANF. Now they are using AVPF with 24 plates. 265 horsepower, 60 horsepower now installed. If I say the consumption, it is 400 units per batch. It is only 35 units per batch. Manpower 8, 2. Floor area, as well as the number of equipment, production capacity, 14 ton, which has become now 16 ton. When we talk about moisture, it is 55% it was, now it is 38%. And this is fully automatic. Next. This is one of the pharma intermediate, API, you can say. Next. Earlier it was 90 horsepower, now it is 25. Wash liquid 200 liters per ton, now it is 50%. Moisture 50%, 35%. Power consumption, you can see the difference. Production capacity is more or less same what they were looking for. Though it was a manual, now it is 100% automatic. Next. This is the pigment industry, which we have taken up these things. Earlier that 41 horsepower, now 25 plus 30 paraffinials. Wash liquid consumption is drastically reduced from 9.23 KL per ton to almost about 5.32 KL per ton. So wash liquid consumption per day has gone down. Moisture was 33%, now it is average is 22%. That is the thing. Footprint area has been reduced to 1/3. Production capacity basically the same. That is the thing, and it is fully automated. Next. We have also installed the equipment for the effluent treatment, because ultimately effluent also is, you have a cake which is drier that will have a better, handling and other things. So instead of settling pond, they have installed the equipment. This footprint area, but natural, it is there. Capacity is there. Earlier the moisture was around 55%. Now it is 20%. So cake can be easily handled and transport anywhere, wherever you want to discharge it. That is one. Next.
Mr. Makwana, can you please conclude? We are getting delayed. That's why.
Okay. Next. These are different case study. This is already there in
Yeah. I think
next.
Everywhere you can see the benefits conclusively.
See, because of, we are 2002 onwards, 2002 company.
Yeah.
Today we have got a global presence with the local support. That is the thing. Next. With this, welcome to Rotofield. We started with thank you and we welcome you all.
Thank you, Mr. Makwana, for a very nice presentation. Now I'm going to hand over the mic to my co-chair, Rupar, who can possibly sum up and also handle question answer sessions before I will try to conclude it. May I hand over the mic to Rupar to try to conclude and offer his comments on today's presentations, as well as look at if there are any specific questions which we would like to take up.
Yeah, thank you, sir. So first of all, let me thank you, the panelists, for educating us on a wide range of areas pertaining to sustainability. The presentations by Mr. Andan wrote the preparation, and the last one by Mr. Makwana were very focused on use of certain technologies and innovations which are applicable to such largely used industrial processes. And one can only imagine the potential as a large cross-section of industries start to adopt these innovations. So you could see that, not only does it reduce water, it reduces energy, it reduces waste, it reduces cost. We need to remember that the biggest problem being faced in the world today are around sustainability, and therefore they will also present the biggest business opportunities. I thank Dr. Harman for her presentation on behalf of Lanzatech. Can I just request people who are not speaking to mute their mic, please? Thank you, and my apologies. I thought that her presentation gave us a sort of a peep into the future. And, that is how we are going to move forward and take steps in moving towards a circular economy. And the fact that we are going to rely increasingly on biological processes. It is interesting to step back and think that the biological processes that exist in nature, millions and trillions of them, are the most sophisticated, far more sophisticated than anything that we've ever done. They are most efficient, and they are absolutely 100% circular to the last molecule. It's interesting to kind of step back and think something that we already know. And then Mr. Mukesh from Solvay, it is so encouraging to see that great companies like Solvay have taken the lead and are showing the way in terms of providing sustainable solutions and adopting a wide range of technologies for a cross section of applications. It is indeed very encouraging. I'm remembered by one of the speeches I heard, which was made by the United Nations Secretary General. And one of the things he was very alarmed about, and he said, look, we are losing the race. And I hope that all of us together can actually prove him wrong. He would actually be happy to be proven wrong, I am sure. And, it is, to me, and I'm sure you would agree, we are again reminded after about 200 years of industrialization that the game is not really about conquering nature. It is not even about trying to save nature, because nature is too big for us to feel arrogant about trying to save nature. And it is really about ensuring that nature has place for us as we move forward. So a lot of our contribution in our own way would be around aligning to nature, learning from nature, and then in the process contributing to nature as one of the living entities within nature. It was very useful and enlightening and encouraging to see these presentations, and I hope all of you found them useful and encouraging as well. So thank you once again to all the panelists, and I think now we can quickly open for a few questions. Is that what you wanted me to do, Dr. Pandit?
Yes, please. If there are any specific questions in the chat box which you would like to take up, we can. Otherwise, depending upon the advice of ICC, I'll make some final comments and we can conclude.
Right, sir. So I haven't seen any questions in the chat box. And given the paucity of time, maybe you could just take over and do the concluding remarks.
Yeah, thank you, Rupak. And you indeed summed up very, very nicely what was covered. I would just like to add a couple of things to what you already said. Learning from nature is going to be the key. So as you correctly pointed out, that we don't want to think in terms of conquering nature. We don't want to think in terms of taming nature. We want to think, or we should think in terms of be with nature. Whatever nature has given us, we must necessarily be and merge and unify with the nature. Now, in the line, there was one comment which was in the chat box is related to how sustainability can be brought into education. Now, indeed, it is being brought into. Now, I remember my school days. In my school days, there was no such subject as called as EVS, environmental studies. The environmental studies as a subject started coming into school syllabus only about 20 years ago, at the most 15, 20 years ago, not before that. Similarly, what we are doing, I'm associated with one Wipro Foundation, which has taken initiative to introduce the concept of sustainability at the undergraduate engineering level itself. Every subject which is taught to an undergraduate engineer or a student, how it can be thought in terms of bringing in the aspect of sustainability when that subject is taught. So when he starts practicing the learning of that particular subject, the sustainability is always at the back of his mind. Now, this is how we are going to train our graduating engineers to come up with the processes, to come up with techniques and technologies which are going to be in tune with the nature, learning from nature, be in tune with the nature, and this is what is going to allow us to have a sustainable future. Thank you very much again on my behalf and on behalf of ICC to all the panelists for sharing their views and for sharing the exciting development which is happening in the area of sustainability. And as correctly pointed out by Rupak as well, is majority of the multinationals are seriously thinking in terms of sustainability as their major motto, because they have been in existence for the past 150 years and they would like to be in existence for the next 200 years. Thank you very much again. And I would hand over the mic to Mr. Mishra to make concluding remarks.
Thank you, Dr. Pandey. Thank you, Mr. Saraswat. Thank you, all the panelists. It has been wonderful. It's been a wonderful journey into the future, the way we are trying to develop technologies that would be sustainable and will take us sustainably into the future areas. And what another thing, we saw the global multinationals walking into this area. And the other aspect that also we see that has come up in terms of the Atmanirbhar Bharat, that we have special entrepreneurs, we have companies, Indian companies, that are also focused on developing technologies that would bring up sustainability, not only in Indian companies, but also in global companies. So thank you all for a wonderful session. And I must add, as it was mentioned by Mr. Makwana, that we have the company profiles, some of the videos of theirs in the exhibition, and they have some of the representatives also that you can chat with, and so that you can take it forward from there. So thank you once again. Thank you, Dr. Herman. Thank you for joining in middle of the night from USA. And we have almost 200 participants in this session, and I'm sure they'll all take these developments home. And the main thing about this is that this is not the end. The technologies that you've shared, the areas that we have shared, this is beginning of a journey, beginning of a continuum of a journey. So thank you once again to all of you. And we'll invite, we are going to have a break now. So even those participants who are here, they can, during the break also, they can visit the exhibition. And then we are going to reassemble at 2 o'clock, where we are going to look at promoting resource efficiency and circularity. And we'll see some more case studies from companies and others in terms of the technology that they are bringing in for sustainability. Thank you very much. Have a great day. Thank you.